So we develop a new cancer therapy. With traditional chemotherapy, which is still very widely used in cancer patients, you basically give this toxic substance, a chemo drug, to a patient. You usually give as much as a patient can tolerate, and then you hope enough of the chemo drug goes to the cancer cells where you actually want it to be. But usually only a very, very tiny amount, maybe 0.1%, goes to actual cancer cells. The rest goes to other organs and tissue where you don't really want it to have. And because of that, it happens frequently that you don't get a sufficient amount of the chemo drug to all the cancer cells. Some of them survive. The cancer grows back. That's called cancer recurrence, which obviously you don't want to have. So what we did is we take the same chemo drug, we put it into tiny lipid or fat particles. So they are very tiny. They may be 1,000 times smaller than the width of the human hair. And once we put them into these particles and we inject the particles into a patient, which is what you usually would do with normal chemotherapy, the particles keep the drug encapsulated. It doesn't go to the organs and tissue and basically protects the drug from being taken up. So now these small lipid particles are made so that they're heat sensitive, which means if you expose them to mild heat, they release the contained chemo drug. And with mild heat, I mean heat in the range of temperatures that you would get in a hot water bath, so not something that would hurt any tissue. It's just for releasing the chemo drug and going it to where you want it to be. So now we have these lipid particles. In addition, we developed a precision heating device that can heat the tissue exactly where you know the cancer cells are and where you want the drug to be delivered. So with our approach, we can get up to 30 times more drug to the targeted cancer cells compared to conventional chemotherapy. And that way we can ensure that all the cancer cells get a sufficient amount of drug, we kill all the cancer cells, and we eliminate the recurrence of the tumor that you get with conventional chemotherapy. If we just take the tumor out, which I do in many of the patients, in our mice, 100% of them had the tumor grow back. If we just give the chemo drug, it delays the growing back of the tumor, but still 100% of the mice got a tumor recurrence. And if we combine our heat-sensitive lipid particles with a precision heating device, we were able to cure more than 80% of the mice in comparison.